Okay. Subtract 2 from each x coordinate and add 3 to each y coordinate. So we get A is 0, 4, B is -5, -2, and then C 3, 2. The x, you're going to count each point to the x-axis and then count the same number on the other side. So for example, A is 1, 2 away from the x-axis, so then you count 2 on the other side. So A prime would be down in here. And then B is 1, 2, 3, 4 from the x, so we're going to count 4 on the other side. And then C is 2. So we get our A prime, B prime, C prime, D prime. And remember that they should look to be the same size, same shape, because it is an isometry. It should preserve distance. And think about if you were to fold it on the x-axis, everything should match up nice and pretty. Okay? All right, we're going to list our new ordered pairs by looking at our graph. So A started out as 2, 2. Now A prime, its image point, is now at 2, -2. So we're just going to list that. And then now B is at 1, 2, 3, -4. And now our new C is down here at 6, -2. And our D is at -4. So if you look at those ordered pairs, what do you notice? What pattern do you see between the original? The y is negative. Yeah, the y changed. So our rule means that we're going to take every point and we're going to change it so that the y is the coordinate that changes. It doesn't necessarily have to be negative. This means the opposite of y. Okay? So D would be 1, 2, 4, 6. And again, you want it to look like a mirror image, so if we were to fold it on the y-axis, everything would match up nice and perfect. So now A is at -2, 2. B prime, I don't know why I have it so far over. It's this point right here. B prime is at 1, 2, 3, -3, up 4. So when you look at the ordered pairs, what happens? What's the pattern? Yeah, the x changes. So we're going to take every point and we're going to take the opposite of the x, comma, y. So that's the rule for reflection over the y-axis. Now keep in mind, guys, when we say -x, we mean the opposite of x. So like if I had a point that had originally started, let's say I had this point here, point E, and I want to reflect over the y-axis. This is at 1, -1, like -1, 7. I reflected over the y-axis. It would now be at +1, 7. So that x up here just means the opposite. So if you start out negative, your image will now be positive. If you start out positive, your image will be negative, okay? So it doesn't necessarily mean negative, it means the opposite of. All right? Okay, then we can also reflect over some lines, any line really. We're going to look at horizontal and vertical is the next part. So we're going to reflect over the line x equals 7. X equals 7 is a vertical line that goes through the x-axis. Okay, so 1, 2, 4, 5, 6, 7. So we're doing this line. You're going to reflect over that line, x equals 7. And then on the next one, where do you think y equals negative 1 is? Is that a vertical line too? Y equals negative 1. Hello. Horizontal. Thank you. All right, so I'm going to give you a few moments to do those two reflections. This one's so important, guys, is because when you take algebra trig, algebra stats, a little bit in algebra 2, we talk about taking a function. Do you know what a function is? Give me an example of a function. Output, input, yes. So, for instance, all those lines that you all graphed last year in Algebra 1, you know, like x plus 8, or f of x equals x squared minus 3. If we take these graphs and we reflect it over the line y equals x, it gives us what's called the inverse, okay? And so that's what this is going to catapult you into next year, okay? Y equals x is sometimes called the identity line. What's the slope of y equals x? 1. What's the y-intercept? 0. Good. All right. Yes, this is on the next page. So you need to graph your trapezoid again.